Welcome to today's webinar, which is the top 10 transformative technology trends for 2021 and into 2022. The last time I saw this presentation was December, and there have been some fantastic updates, so I'm looking forward to hearing it as well. So the Industrial Internet Consortium webinars are designed to be educational and informative, and we highlight what the consortium members are doing in critical areas of digital transformation and how to leverage the Internet of Things for success, business success, as well as technology success and development. So joining me today, I have Chuck Byers. Chuck is the Associate Chief Technology Officer for our organization, and he's extremely active with the Industrial Internet Consortium members and contributes to a large number of our task groups and working groups and publications. He speaks at forums and workshops for the Industrial Internet Consortium, as well as representing us at other speaking venues. So today's presentation is available through the attachments button on your Break Talk dashboard, and we love questions. So please send us as many questions as you like, and we've reserved 10 to 15 minutes at the end of the session, and we'll get to those then. If you have any follow-up questions for Chuck, I have added a link to his LinkedIn profile, so you can get in touch with him there. And of course, you can always fire off any questions at any time to us at info@iiconsortium.org. Now, so enough of my chatter. I'm going to get Chuck started here, and I will talk to you when we're done the speaking portion of the presentation. Thanks again for joining.
Hello, everybody. This is Chuck Byers, and I am the Associate Chief Technical Officer of the Industrial Internet Consortium. Thanks for coming, and today's talk is Top 10 Transformative Technology Trends for 2021-2022. Our goal really is to talk a little bit about what we think the future holds and how you can be involved creating that future. I'll go ahead and share my presentation for you now, and we can get started. All right, here's our presentation. And basically what we're going to do is talk a little bit about how IIC manages future trends, especially what we call transformative trends that are really out there, kind of things that may not be on everybody's radar screen today, but we think are likely to be really important characteristics for future technology solutions. Let's have a look a little bit at what we think is the basis for these transformative technologies. First of all, we think technology in general is really key to the mission of the Industrial Internet Consortium and its members. We're going to define transformative technologies as those that we may not currently know very well or be using in the systems that we're implementing, but we think are going to have a great impact on the Internet of Things and digital transformation, starting out in the next few years. IIC's got this goal of continuously being on the lookout for the next big thing and figuring out how we can leverage our membership and our processes to make those next big things a reality. The success of our consortium, as well as our members, really depends upon us keeping this list of current transformative technologies up to date. Once we identify the technologies that we think have the most promise for the future, we would really like to integrate those rapidly into the work plans that IIC is in the process of executing. Some examples of what we would consider to be past successes of identifying transformative technologies, perhaps a little further out in front of the headlights than other consortia or organizations might have, and taking these to heart and implementing policies, procedures, best practices, generating reference architectures, and providing lots of interesting content and thought processes around them. These are some of the successes that we think are top of mind from IIC. Trustworthiness is certainly a thing that IIC has pioneered and articulated for the Internet of Things, and that includes 5 dimensions: security, privacy, safety, reliability, and resilience. We have lots of work after sort of discussing and discovering the great benefits of trustworthiness to the Internet of Things. We've gone really deep on providing lots of value around the trustworthiness technologies for our members and the ecosystem at large. We've got lots of activity on blockchain. I think everybody knows what that is, but we've been pioneering the application of blockchain into Internet of Things and digital transformation. Digital twins are something that we are particularly proud of our track record in, because digital twins have really blossomed. We started this basically as a wild idea and work group, technology group that was defined in IIC. And we basically grew it up to the point where it's its own consortium, namely the Digital Twin Consortium, which is a sister organization for IIC, both inside of the Object Management Group. I think that predictive maintenance of machines is something that IIC was really a pioneer in and has gotten behind in a big way. We have lots and lots of test beds and lots of really interesting thought processes related to predictive maintenance of machines. Digital transformation, I mentioned before, is really taking the information technology and operations technology of companies and mashing them together using digital techniques for digitization and digitalization of those processes to try to pull them into the computer age and get lots of benefit out of them. And finally, one that's really close to my heart is edge computing. It's a thing that IIC has been behind for almost 5 years, and it represents really the next step, I believe, in the way networks are going to be designed, especially networks that have to do mission-critical, life-critical applications. In fact, I'm so behind edge computing, I'll take a little digression here and throw in a plug for a Journal of Innovation, which is just hitting the virtual newsstands this week. The Journal of Innovation is about 3 or 4 times a year a publication of IIC, and we tend to have individual focus for a particular issue. This issue, the June of 2021 issue, is entitled Applying Solutions at the Digital Edge, and that URL that's shown right there under iiconsortium.org is available for anybody to download that content. There's 3 or 4 really excellent papers in this issue that I think you get a kick out of. All right, on to ideas in order to keep the IIC flush with good work plans and good relevancy. We're going to energize our members and the task groups and work groups that those members are organized into with new levels of technical ideas and new roadmaps. So it's really about keeping the IIC momentum running. We're going to expand our thought leadership across the ecosystem by showing how we're really looking out behind the headlights, trying to figure out what the next technologies are and be pioneers and inventors and advocates of those technologies rather than fast followers. We have lots of liaison work that we do, over 40 liaisons with various standards development organizations and other consortia, as well as lots of outreach with our academic partners, universities, government laboratories, and so on. And we think that this study is going to help us inform those kinds of efforts and those kinds of synergies. Certainly a little of a self-serving goal. IIC needs to build its own brand recognition and help recruit new member companies. And we think that technology is an ideal way to do that, especially advanced technologies. A sense of fun and excitement for the members, a reason to come to that that meeting that we hold virtually every 2 weeks for something like a work group or task group. And then finally, the technology always involves a bit of gazing into a crystal ball and figuring out what's next, placing bets on technologies that we think are likely to be very important commercially in the future. And we think this study is really going to help us do that. And certainly we want to facilitate a clearer viewpoint of what the future holds. Here's a process that we use to select and down select the top 10 transformative technologies that I'm going to start talking about in just a couple of minutes. So IIC staff, including myself and many of the other leaders of the Industrial Internet Consortium, we kind of did a literature search. So we looked in scholarly journals, we looked in websites of various companies, we looked at all of the analyst websites, the Gartners and Forresters of the world, and we came up with 110 raw ideas. I even watched some PBS specials and got a couple. In the December 20th member quarterly meeting, we brainstormed among the members present and solicited the work groups, the technology working group, security working group, marketing, and so on, for additional ideas. So that list of 110 ideas expanded out and eventually consolidated into 87 ideas. Then we asked the membership to rate them on 3 different dimensions: time scale, sort of this year or a couple of years or 5 years out. Then we also rated them on economic impact. Is it a 10 million, 100 million, or $1 billion idea? And relevance to IIC's mission. So is it in the middle of IIC's wheelhouse? Does it seem like it's something that IIC should get involved with? And we basically rated them and color-coded them, recorded those ratings. And then we used a multi-vote system to rank the 10 most promising ideas. And the ones that bubble to the surface are the focus of the rest of the talk. We also took those ideas and worked with the chief technical officers across the object management group, of which the Industrial Internet Consortium is one member, but there's also Standards Development Organization, Digital Twin Consortium, and a few others. We asked those other CTOs to sort of help understand the synergies across those groups and across the industry. And we got lots of really interesting input that I'll highlight on each of these slides about where the thing fits in the overall ecosystem and what organizations might be interested in it. And this is a dynamic living list. It's not static and done. It is something that we will update on approximately an annual basis as the technologies on the list either come to fruition in IIC as a project or a deliverable, or maybe a few of them will wither and die. And then, of course, we want to backfill them with other ideas. So we've always got a big list of fresh new things to think about. Let's take a look now at each of the 10 top transformative technologies in sequence. And the first one that we're going to talk about is edge-based artificial intelligence inference or learning. So today, things like artificial intelligence, machine learning, and deep learning are predominantly implemented in the cloud. They're very CPU intensive, they're very storage intensive. That's an inexpensive place to do that. But we've got lots of problems with putting them all in the cloud. Performance, especially latency, and various trustworthiness aspects like privacy, security, reliability. Sometimes we want to move some of those AI workloads deeper into the network, to the edge, or maybe even to intelligent IoT devices. The first thing that we're going to move down there is the inference part of AI, which basically takes a pre-computed model and applies it to maybe sensor readings or user input, and uses that to generate an immediate response. That closed loop, fast real-time system tends to be much more effective in edge computing than it would be in the cloud because of latency and network bandwidth and data gravity kinds of considerations. Eventually, the second phase of AI, the learning phase, the thing that takes a bunch of training data and digests it with very complicated processes, we think that there's opportunities to move that to the edge too. Initially, that'll stay in the cloud because that's where it's really set to go. But eventually, that inference stage will also end up in edge computing. We think that specialized hardware might be useful, especially a thing called a tensor processing unit, which is a special processing device, a special chip specifically designed for AI model and inference work. And we think that there's a lot of software that's potentially going to be important there too. Things like containers and Kubernetes and special security software, cryptography algorithms, and so on. That's going to be moving towards the edge in support of the AI workloads moving there. The Industrial Internet Consortium will probably focus this in the AI Platform Task Force. And also there's a Edge Computing Task Group that's interested in all things edge, including how to put AI there. So this together is one of the top models that we have, and we think that this is going to be a very important trend, shoving the AI functions that's currently in the cloud deeper into edge computing networks. And here you can kind of see where the big brains are. So here's the AI is running typically in the cloud and increasingly being shoved deeper into the network to edge computing. Here's idea number 2. It's about security. This particular one is called zero trust security. This is a type of security where no device, no network, no human is intrinsically trusted without some kind of an authentication process. And the things that are sort of addressed, the dimensions to zero trust security are shown here: data, applications, devices, people, and networks. We trust none of them until they're verified. And we can contrast this with what are sometimes called the walled garden or the air gap approach, where there's a demarcation point in the network between the parts of the great unwashed internet that are not trusted and the parts of your network that you believe are 100% secure and intrusion proof. History has shown that those air gapped and walled garden approaches just don't work. As soon as the bad guys get into there through whatever mechanism they can muster, those networks are compromised. So all of the devices on the network, regardless of whether they're inside or outside of some kind of a cordon, probably need to have their own security capabilities. Some of those security capabilities include things like identity and access management, authentication, orchestration, analytics to discover intrusions, and so on. The security policies that drive these networks are going to have to evolve to support them. And it's really an effective tool to counter this special security and privacy threats associated with IoT. As soon as we start adding actuators onto networks, the hackers can influence the real in very nefarious ways. We think that IIC is an ideal organization to be considering these situations, and we believe that zero trust security is an important augmentation to IIC's security capabilities and the work that's being done in the Trustworthiness Working Group. The OMG work across the Object Management Group is the Industrial Internet Consortium Security Working Group and many of its task groups. We're working on a Trustworthiness Foundation document update that I think would benefit from zero trust security. The Standards Development Organization in OMG has a Systems Assurance Task Force, which has got many security components. And then there's some external organizations, one in particular, the Cloud Security Alliance, might be of interest to zero trust security. Idea number 3 is also security related, but a slightly different take on it. It's called Secure Access Service Edge, and it's sometimes pronounced SASE. Secure Access Service Edge is really a thing that combines the software-defined wide area network technologies that are predominant across networks with zero trust security that we just saw in the previous slide. This was proposed by Gartner, a famous analyst company, about 2 years ago, and it's rapidly achieved commercial importance. So we're seeing companies like Cisco and HPE and VMware all offering zero trust security capabilities as part of the product portfolio and including them in a secure access service edge capability. The 5 key components of SASE are SD-WANs, the firewall as a service, basically a device to build secure enclaves, web access gateways, cloud security brokers, and zero trust network access engines. All of these things together can be consolidated into a really cohesive security package. It's likely to grow in great importance to the Internet of Things, especially as the Internet of Things becomes more important to mission critical and life critical applications across the network. And we think that the security maturity model, which is one of the most famous current deliverables of the Industrial Internet Consortium's security task groups, We think that it needs to grow to include SASE technologies and concepts. Certainly, this function is not just in the cloud. Those same functions that are depicted here in the cloud are going to be driven to edge SASE nodes. So there'll be smaller versions of firewalls and ZTNAs and brokers and gateways in the SD-WAN contexts down deeper into these networks. The opportunities for IIC include the Edge Computing Task Group, the Security Working Group, and the Security Special Interest Group in the Standards Development Organization. I'll try to dig through those acronyms as we go. So lots of really interesting opportunities in the security domain, both with Zero Trust and SASE. Idea number 4 is about advances in optical networking. So right now, optical networking generally means fiber optic networks. In IoT contexts, it's generally in the 10 gigabit per second or so range. We see a great need for expansion on a couple of dimensions there. As IoT, especially edge computing, starts to put more and more load on these networks, we're going to need more and more capabilities for high bandwidth interconnect. We think that wireless is a partial solution, as we'll see in a future version of these slides, but eventually you want to get on fiber as quickly as you can, because fiber is robust and resilient and low cost and secure and all the other things that sometimes are problems with wireless connections. We think fiber is going to penetrate much deeper into the networks, to these edge computers, potentially right down to individual IoT devices pretty soon. And we think that their speeds are going to go up from the sort of 10 gigabits that are common today up to around 400 gigabits. That's a common speed in high-end data centers, but really doesn't go much further than that. We think there's a trend to drive that down deeper into the IoT. Finally, where fiber is impractical, we think that free space optical technologies like visible light communication and Li-Fi may have a place. So what you basically can do is build a wireless interconnect using lasers shooting through the air and not use the precious radio spectrum that you potentially would have to buy at auction. We think the IIC connectivity and networking task groups would be interested in these technologies and revising their frameworks to include much deeper fiber penetration, much higher fiber rates, and the ability to access free space optics and Li-Fi in future networks. So this is an important growth area, and it's really the way the bits that run this whole Internet of Things get carried around much more efficiently. Idea number 5 is about virtual worlds, social extended reality platforms, and remote expert systems. Lots of advances going on in augmented and virtual reality out there. Lots of them are being directly related to the Internet of Things and DX, which means digital transformation. We think that social extended reliability is really about collaborative multi-user environments who experience this for serious applications, not just gaming, not just social media, but things like training and collaboration in medical systems and so on. We think that that lots of verticals will benefit from this technology. We think that some of the analytics and some of the edge computing capabilities that we talked about previously might be involved in this. There are potential synergies in several different IIC and OMG groups, but none come immediately to mind, which might indicate that there's an opportunity for us to form a brand new task group for virtual reality, extended reality, social AR, and so on. And so if anybody's interested in getting in on the ground floor of such a task group, there would be 2 or 3 chairman positions available if we decide to create it, and be very useful for you if you're interested in these technologies to step up and help us formulate a capability for bringing that technology into the industrial internet world. Idea number 6 is really a response to the pandemic and helping use IoT technologies for social distancing, contact tracing, vaccine passporting, and so on. This is all essential to fighting the pandemic and getting us back to normal. We think that sensors and networks can really monitor building occupant safety. Things like infrared cameras and pulse oximeters can determine if somebody is healthy. We can have cameras determine who's touching what, and robots or drones to run around and disinfect those things that were touched. We've already got a test drive proposed by Dell, and this is really a sort of a prototype that IIC and several of our member companies, including Dell, are working together to pull these technologies into a demonstration system. There's a healthcare task group that's driving this in IIC. There's also the robotics task force in the standards development organization that could potentially be involved with things like contact tracing, vision systems, machine vision, and robot disinfection. Idea number 7 is about licensed and unlicensed wireless networks, specifically licensed networks as a way to provide trustworthy interconnectivity for the Internet of Things. So what we're really looking at for digital transformation and IoT is to have lots and lots of nodes connected by lots and lots of network capability. Certainly bandwidth is increasing. Devices that used to make a few kilobits per second are making megabits per second or faster. Radio spectrum is scarce and expensive, and we need to tune up IIC's wireless strategies. We think that licensed services, things like 4G, 5G, and eventually 6G, cellular phone, the CBRS service, private networks that use licensed spectrums, low Earth orbit satellite CubeSats, those kinds of technologies we think are going to be highly applicable to IoT, perhaps more so than the unlicensed wireless spectrum technologies like, say, Wi-Fi or LoRaWAN. The reason for that is if you have a license, you have sort of exclusive use in that technology, and the FCC will help you control the number of interferers that are potentially coming up and causing interference on your services. That's really helpful for things like, say, a pedestrian safety application in a smart transport system, where if you can't receive anti-lock brake notice because there's a nanny cam running in the neighborhood taking up all the wireless spectrum, that's a real problem. Putting that on a dedicated licensed spectrum is much better. So we think that the IIC connectivity and networking task groups, which by the way are likely to merge in the near future, are in the midst of revising their frameworks, and we think that these licensed ideas and sort of the expression of preference there is something that should be added. We also, the CubeSat, the low Earth orbit satellite stuff, the Starlink constellation that Elon Musk and SpaceX are in the middle of lofting, those kinds of things are also being discussed in detail in the Space Domain Task Force that has a reference model that's part of the OMG Standards Development Organization. So lots of opportunities for us to tune up the way that the IoT sensors, actuators, edge computers, intelligent devices are interacting with the cloud and the internet. Idea number 8 is about heterogeneous computing. That's using standard x86/Intel CPUs, ARM CPUs, maybe the new architecture of RISC-V, together with untraditional types of computing resources, which are potentially much more efficient for certain types of applications. And these untraditional types include things like graphics processing units, which can be very useful in massively multi-processor applications like matrix mathematics. There's a new kind of architecture called a tensor processing unit, which is highly optimized and tuned for machine learning and artificial intelligence applications. Field programmable gate arrays are like arrays of individual logic gates that can be configured into complex data paths that can be many times more efficient than you might find in a CPU for certain workloads. Very useful in financial technology, scientific computing, things like drug discovery use FPGAs. Digital signal processors are particularly useful in things like digital filtering, software-defined radio, natural language processing, and speech recognition, all run very efficiently on DSPs. Finally, there's a thing called an application-specific integrated circuit, that is sort of a custom-made chip for a specific application. All of these can be used together in a way that optimizes the right kind of CPU resource for the individual type of workload. I just finished a paper for the aforementioned Journal of Innovation article on heterogeneous computing, where we explored in great detail the trade-offs, costs, and benefits associated with certain kinds of workloads running on different types of these CPU resources. We think that choosing the right resource might lead to a tenfold or more improvement. In fact, for certain massively parallel workloads, NVIDIA claims that their GPU arrays are up to 50 times more efficient than similar technology implementations for x86 CPUs. Striking, and it's an important differentiator in the market if you choose the right implementation technology. We think that where IIC can jump into this, we're obviously not going to design chips, but we could help with the orchestration of heterogeneous IoT and digital transformation environments, figuring out where to run certain types of workloads in the cloud edge IoT device hierarchy, and on each of those levels of the hierarchy, which of these types of computing resources are most optimal for that workload. IIC could also potentially jump in and coordinate the different companies in this space, Intel, ARM, AMD, NVIDIA, and so on, to try to make a sort of more cohesive, interoperable viewpoint, something that would be more like a standards-based approach to this, rather than the sort of ad hoc, different proprietary software packages that are currently used. Certainly opportunities in IIC's management task group, and if we have performance or energy sensitive applications, I think we got lots of opportunities to make the best of our decisions. Idea number 9 is really about operational maintenance and virtual reality customer support. So think about the technicians who are out repairing equipment. So here you see a technician looking at something, must be a compressor motor, trying to understand what's going on, and the augmented reality system on his tablet is showing exactly how all this stuff goes together and what the sensor readings and safety protocols are for each of the operations that he might be performing. We're really trying to improve the human experience, the user interface for maintenance workers and so on. This is really an important lever to try to get these augmented reality functions, virtual reality functions, more deeply into the digital transformation landscape. We think that there's an occupational safety test drive. It's a thing really about making sure that users have the proper personal protective equipment and are performing their jobs safely. And that test drive is active in IIC right now. And these AR, VR technologies, we think, could be an excellent augmentation to that test drive. It could also be a very effective demo for future manufacturing related work that IIC might be doing. So we think that there's lots of opportunities for us to take a little deeper look into this technology and to try to weave it throughout some of the work that IIC is doing. The last idea is certainly the most speculative, and it's about quantum computing and quantum entanglement. Lots of buzz about this. The picture that you see is a beautiful inner workings of a quantum computer, and the actual qubits, the active elements, are right at the very bottom. This thing gets colder and colder as you go down these cascades to the point where it's a few hundredths of degree Kelvin above absolute zero at the bottom where the qubits reside. Very complex stuff, but it has certain really important advantages to certain really limited sets of problems. In particular, it can do things like searches and database manipulations much more quickly than conventional computers can do. There's an opportunity potentially for quantum computers to crack cryptography keys instead of taking thousands of years as a supercomputer might take to guess a 256-bit key. The properly designed quantum computer might do that in seconds. That's a serious threat to much of the security and trustworthiness work that IIC has been doing. So we want to keep quantum computing, especially post-quantum cryptography, after these capabilities to crack keys are well understood and deployed, we want to understand what ISC should be doing to maintain the security of our network in the presence of quantum decryption. And probably the thing that will be involved there is quantum encryption. So we have to fight fire with fire, basically, and use quantum technologies to build more robust encryption systems for our IoT links. This is really speculative. ISC doesn't really have a lot of experience on things like hypercold refrigerators and squid devices. So I don't think we're going to necessarily be technology innovators there, but I think we could be innovators at the application of this technology, especially in the Internet of Things. I think that this is probably going to go on a back burner for a year or two, and then we'll revisit quantum computing, see if post-quantum cryptography is real, and then decide whether or not we should spawn a task group about it. So we'll just kind of leave it on the parking lot for a cycle or two and revisit it next time. But I put it on here for completeness so that you know that IIC is looking at things in the deep future and triaging our list appropriately. The next steps and status is really let's introduce these top 10 ideas into the Industrial Internet Consortium groups that are going to shepherd them. We've already done that. We've already rolled this out to each of the ideas. You know, a couple of security-related ideas have been proposed and vetted in the security task group. The edge computing task group has seen the edge-related ideas. There's a machine learning task groups that are looking at the AI-related stuff, and so on. They're all charting their own path, but perhaps integrating these ideas into their existing structure and their existing workflows and deliverable plans. Or in a few cases, we're probably going to end up creating new task groups that are focused on these emerging technologies. And we've done that before. So we created a new task group, for example, around the concept of digital twins. And that took off to the point where we actually kicked it off into its own consortium, namely the Digital Twin Consortium. That's a thing that is one of our sister organizations in OMG, and it's going great guns. We think that there's lots of opportunities for synergy and identifying synergy between these ideas and other OMG programs across the Standards Development Organization, across the Digital Twin Consortium, and so on. So we're not doing this in a vacuum. We're also not just limiting our interactions with OMG. We're also looking outside to academia and the organizations where we have liaisons. A few other things that are going on is as the ideas start to gain traction, we're going to take steps to publicize them with our thought leadership. So opportunities like this webinar, the Journal of Innovation, we do quite a lot of white paper publication. We've got a lot of opportunities for speaking from various podiums and various conferences, and all of these will help us pull this out. Eventually, we think that these ideas, at least a good subset of them, are going to be integrated into our work plans and suggest absolutely new initiatives for the rest of 2021 and 2022. We're collecting additional ideas for the next round of these transformative studies. So we're really interested in your ideas, your thoughts. Is there something that we missed? Certainly there were other ideas that were nominated but didn't receive the votes to make it to the top 10. We're not losing those. We'll just re-vote on them next year. But if you see any ideas that you really think ought to be here that aren't, we're really interested in your feedback on that, and we'll add them to our list of things that we track. That is the end of the formally prepared talk. And I guess right now you can see where to reach me there. If you go to the Industrial Internet Consortium, you can kind of see how all this is. You can receive that Journal of Innovation article that we talked about. And at this point, I think we are ready for questions and answers.
Thanks, Chuck. That was great. That was, really informative, and I had been looking forward to hearing the update since December. So if you can go, yep, perfect. Thank you very much. And now I can switch my video on just for a moment. Want once again to remind everyone, this is based on one of the questions, by the way. one of our viewers asked how to access the presentation and the Journal of Innovation. I just want to make sure that everyone knows those are available through the attachments dashboard. You can download today's presentation. You can access our Journal of Innovation publishing this afternoon or at the latest tomorrow morning. And Chuck, we have about 4 questions that have come in.
Okay.
You can see those if you click on the green question button there on your presenter dashboard.
Oh,
But I will, what I'd like to do, if okay with you, is I will shut off my video and I will post the question as you answer it. So should we, you choose the one you want right now, and I'll post that so everyone can see the question as you answer.
Okay. Let's go ahead with. Let's talk a little bit about how these. Let's go with this one about the increasing number of companies are building their own private 5G network and eventually 6G networks, and what are the roles of these private networks in the industrial internet going forward? An excellent question, and my answer is that private networks are helpful under certain circumstances, especially if you have highly critical applications, life critical or mission critical applications, a thing that's in series with the production machinery in your multi-million-dollar factory, a thing that might be, for example, managing patients' ventilators in an ICU. Those kinds of functions are too critical for public networks, especially public networks that use the non-licensed spectrum. So I think that private networks are going to find first opportunities where we see lots and lots of critical applications in sort of the same place. Then it pays to put in a public network, or it pays to take a public network, maybe slice off a little bit of that spectrum with spectrum sharing options, and then use that as a spectral basis for the installation of a private network. You would probably go with 5G for the next 3 or 4 years. I wouldn't recommend 4G private or LTE private networks at this point, because that technology is going to start running out of gas during the lifetime of the devices that you're likely to install. So if you put a bunch of 4G modems in, say, a bunch of ICU equipment and expect that to be available forever, it might not be, because those networks might move on before the life cycle of those devices is over. So starting with a more modern technology like 5G, I think would be an ideal solution, even though it might be a little bit more expensive. So private networks definitely have a place. Critical applications first, and eventually they could roll out a little bit deeper into the network. All right, let's go on to another question. So how do these, are there synergies between different numbers of the top 10 list? And I think the answer is yes. There's a lot of synergies out there. Things like the 2 security aspects that I talked about, Zero Trust Security and SASE, I think they have excellent synergies with, for example, the networking functions that we talked about, the optical networking and the licensed spectrum networking. So you want to grow up the interconnect capabilities and the security capabilities hand in hand. And I think that's an example of a synergy. Another example of a synergy might be those virtual reality and augmented reality and XR functions that we talked about. They have real interesting synergies if parts of those things are implemented at the edge. You want to have very sophisticated computing to render the images fast, and that sophisticated computing is going to weigh down your glasses and drain down your batteries really fast. If you did all that rendering and computation, say in an edge computing node, and then you pulled back just video onto a lighter weight, more battery-friendly pair of glasses, that could potentially improve the user experience by making the rendering really fast and the headset really light. So those are examples of synergies, and I'm sure it's a fully interconnected matrix. I'm sure quantum computing is somehow involved with much of this stuff, and so on. So yeah, there's lots of opportunities, and in fact, many of the most important opportunities in the industrial Internet of Things are between or staggering across a couple of different vertical markets. All right, let's go forward. talk a little bit about green technologies and sustainability. We actually had about a dozen green technology ideas nominated as those 80 some raw ideas that we talked about. Just for whatever reason, the voters didn't show them enough love and they didn't make it onto the top 10 list. Some of the green technologies that are out there are things like energy efficiency, renewable power for power grids, driving deep into IoT networks with those renewable energy functions. We also talked about energy efficiency in smart buildings and smart factories and smart cities. So, for example, you might control lighting and heating and ventilation and other things with an eye on energy, not just an eye on safety or occupant comfort. And opportunities for IIC to control that stuff certainly abounds. Other things in terms of greenness and sustainability could be related to recycling and upcycling and efficient use of raw materials in industrial and factory applications. IIC is certainly involved in things like, for example, using a camera to take a look at a board that comes off the sawmill to figure out how many slices to cut it into optimally to optimize the efficient use of that raw material. That sort of function is something that the IIC industrial task groups have been working diligently on, and much of our work is already well deployed in the industry doing that kind of green stuff. Green is a focus that IIC membership and IIC leadership has discussed as important to our future. And we don't necessarily want to be just the green brand, but I think we do want to be cognizant of the fact that everything we do needs to think about how to keep stuff green. All right, another question came in about zero trust security. How far is this already a topic in bigger companies? What's the best way of a company to start with a topic? Is it on top of an existing IT, OT security strategy, or is it possible to include it right from the beginning? There's a couple of ways to do zero trust security. One, and perhaps the most straightforward, is greenfield, where you start a new network and you design it from the start, zero trust security, including those devices that we talked about and those capabilities that we talked about in zero trust security. So you're worried about securing the different aspects of the system, people, devices, networks, and so on. The second and probably more common approach to deploying zero trust security is what we sometimes call the brownfield approach, where you already have an existing network. You may have a walled garden, you may have a firewall, you may have an air gap portion of your factory. And what you have to basically do is think the way that a hacker would think about attacking that network, and start with the highest value targets, the ones with the most security vulnerabilities, the ones that have the financial data on them, for example. And you want to expand the capability of that individual node to have all the zero trust security capabilities. It's got to have all that authentication and all that protection capability in it. And then eventually you'll go around and do an audit of all the devices on your network, making sure that they conform to some kind of a zero trust security policy, at least some minimum level of zero trust security capabilities. And then you can start decommissioning those firewalls, and you can start closing up those air gaps with carefully chosen networking functions in order to actually improve the connectivity of your network while not compromising on its security. Every node in every factory is eventually going to have to access the internet cloud. There's just no way that you can efficiently run a machine without being able to access the internet. The trick is to use technologies like zero trust security to keep those accesses absolutely safe and trustworthy. And it's not an easy process, and it's an ongoing process. Zero trust security is a thing that's going to keep cranking, and we're going to have to keep expanding as we go. As we learn more, we'll have to add additional capabilities. The next question that we have here is, how do these transformative technologies find their way quickly into products that are made by IIC member companies? So how does an IIC member company leverage the work that we're talking about with these transformative technologies in order to beat their competition to market with the ones that are becoming important? IIC membership is kind of a two-way street, in my opinion. One thing that a company who joins IIC gets out of that membership is the ability to influence the marketplace through IIC and its leverage of 160 companies across that ecosystem. So if you, for example, are expert on a certain technology in your company, or you have a product in development that offers a certain capability, you might want to make contributions into IIC that somehow benefit or at least anticipate the work that you do, the expertise that you have, the capabilities of the products that you do or will soon offer. And IIC welcomes, within reason, your argument and advocacy for technologies that you know something about. That's the way business is done. That's the way standards have been made. That's the way consortia like IIC operate at the benefit of their members. So the first of the two main benefits of IIC membership is your ability to influence what IIC talks about in the future, and indeed what we choose for next year's transformative technology list. The second benefit is kind of the opposite. If you're sitting in an IIC discussion, bi-weekly task group meeting, for example, a 1-hour video conference call, you may hear things that give you ideas about which way to drive your roadmap. And these transformative technologies are going to perk up a lot of people's ears across these technologies and across these technical working groups. So what you want to basically do is say, aha, that's a thing that my current product roadmap doesn't support, but probably should, because IIC has identified that as one of these transformative technologies. Take that back the next time you have one of those roundtable product roadmap evolution, drive it up into the right sessions. That's where you start mentioning the things that you learned about first in IIC, and that's how you leverage IIC's collective insights to help you keep your own product roadmap fresh and to keep these capabilities inside of your company.
Hi, Chuck. I'm jumping back in. We've almost reached the end of our allotted time, but there's one question that I'm going to seed in there myself. Okay. And I would like you to just mention the how to get involved with the IIC and why to get involved with the IIC.
Excellent question.
And then you can close it up. I'll just listen.
Will do. Thanks. So how to get involved with IIC is certainly, even if you're not a member, you can run in and grab thousands of pages of useful information, hundreds of hours worth of video available for free for anyone to download from our website. And that information is really driving many aspects of the industrial internet and digital transformation across the globe today. So even if you're not a member, learn based on what IIC has provided for you. However, you should definitely consider the advantages of membership. You get to join those committee meetings where the future is invented. You get to have potential leadership roles by chairing committees or editing documents or producing webinars like this or speaking at conferences on IIC's behalf or with IIC's support. So that's an opportunity to jump in and join. There's 3 or 4 different membership levels, including a newly created free membership level for the first year for low revenue startups. Startups are really an important and most welcome dimension to IIC's membership, because that's really where the innovation happens fast. That's really where the big ideas get incubated. So those are some of the things that you can do. In terms of the other things, basically just enjoy the ecosystem and do what you can to promote concepts like trustworthiness and performance and versatility and modularity and all the stuff that we talk about in IIC and part of your daily life. You'll find that these ideas are universally appealing to folks who work on the kinds of things that we do. I think that's probably it. I'd like to thank you all for your attention today. I apologize for the few hiccups around minute 12. I've got a thunderstorm here in Chicago, so I wonder if that might have had something to do with it. And hope you got something useful out of this meeting and this webinar. and I hope that you'll follow up with learning a little bit more about transformative technologies and IIC's role in promoting them. Thanks, and have a great day.
Thank you, Chuck, and thank you everyone who joined us live today. The presentation will be available on demand, and you'll receive an automated notice when that is posted. Thanks again. Have a great day.
Bye-bye.